Hi guys, Digital Principal and Computer Organization. The subject code is CS3351. Unit 1 Combinational Logic, and this is the 7th part video. In this video I am going to explain you about what is meant by encoder and decoder. What is meant by encoder? What is the use of encoder in digital circuit? A combinational circuit that changes the information into n output lines are known as encoder. The binary information is passed in the form of 2n input and output line define the n input. It means if you are going to give an input value as 2n, okay, with the help of the encoder you will get the output as only n. So the 2 get cancelled when the input is converted to the output by using the encoder, and the encoder performs the reverse operation of the decoder. So the producer n bit output. So this n bit output is equivalent to the binary information. The binary information means either it will be 0 or 1. This is the block diagram of encoder. You are going to provide the 2 to the power of n input values, and here you will get the output as only n values. For example, if you are going to provide the 4 as input means you will get. So, how will you write this 4 in the 2 to the power 2 to the power of 2? This 2 is the end value. In encoder, if you are going to provide 4 input, you will get the 2 as the output. So, this is the explanation for 2 to the power of input line, you will get an n output line. If you are going to provide 8 input means the 8 is written in the 2 to the power of 3. So, your output will be 3 here when you will use the encoder. 8 input means you will get 3 output. 4 input means you will get 2 output. There are various type of encoder. Here I am explaining few of them. First one is 8 to 4 to 2 line encoder. Another one is 8 to 3 line encoder. In 4 to 2 line encoder, you need to provide 4 input to provide an 2 output. In 8 to 3 line encoder, you need to give 8 as an input to get 3 output. First one is 4 to 2 line encoder. The 4 to 2 line encoder is mentioned, the input value is mentioned with y0, y1, y2 and y3, and it's going to provide 2 output, a0 and a1. If you are going to provide the 4 input, right, if any one of the input is true, you will get an output. Get an output. This is the block diagram of 4 into 2 encoder. So mention that y0, y1, y2 and y3, this will be the 4 input connected with the encoder to provide an output as a1 and a0. Input and 2 output encoder. 4 input, 2 output encoder. It has 4 input. One is mentioned with y3, y2, y1 and y4, and output will be given as name a1, a0. When y3 is given as high input and the remaining 3 input will be given as low, that is 0, you will get a value as output 0 0. When you give the second input as 1 and remaining 3 input as 0, that is low value, you will get an output as 0 1. Afterwards, if you give high input for y1 and remaining input will be 0, you will get an output as 1 0. For final input is given as high input and remaining will be low input, you will get an output as 1 1. And this truth table is filled with the shortcut. You need to fill from first cell as 1 and you need to fill the 1 diagonally. Okay, see this, it is in diagonal position. Afterwards, A1 and A0 output is filled with 0 1 0 0 1 1 and 0 1 0 1 concept. With the help of this truth table, you need to draw K-map. In my previous video, I will mention about how to draw the K-map with the help of this truth table. After doing grouping method in K-map in the form of sum of product method, you will derive this equation, output equation A1 equal to y3 plus y2 and A0 equal to y3 plus y1. This is the equation of 4 by 2 encoder. This is the logical circuit of 4 by 2 encoder. So here we will have y3 and y2 is performed by the OR operation. Again y3 and y1 is performed with OR operation. See here y3 and y2, it is performed with the OR operation to provide an output as A1 and the A0 is equal to y3 plus y1. One of the input is connected with the y3 and again and one input is given from the y1. This is the logical circuit for 4 by 2 encoder. Next encoder is 8 by 3 encoder. In this encoder you will have 8 input and it's going to provide you 3 output. And this encoder is also known as octal to binary encoder. There will be a total of 8 input y0 to y7. Okay, the input name is mentioned from y0 to y7 and the output is mentioned with the variable as a0, a1 and a2. The same procedure is followed in the 8 input 823 line encoder. So one input line is set to true at a time to get the respective binary code in output side. It means if you have 8 input, right, but each time you need to give only one input as high value and remaining 7 will be as low value, that is it has to be given in 0 to get an output. This is the block diagram of this is the block diagram of 8 by 2 8 by 3 encoder and the input is mentioned with y0 to y7 y0 y1 y2 y3 y4 y5 y6 and y7 and the 3 input will be a2 a1 and a0. The same procedure is followed in this 8 by 3 encoder. So for first you need to fill y naught as 1 and the remaining 7 values will be 0. During that time you will get an output as 000. Afterwards, next time you need to give high input for y1 and the remaining 7 input will be 0. This time you will get output as 001. Third time you will give high input for y2 and remaining 7 input will be 0. You will get an output as a2 is 0, a1 is 0, a1 is 1 and a0, a0 is 0. Likewise, you need to give in high input for only one input among this 7 and among this 8 among remaining 7 will be considered as 0 at a time. In exam point of view, you will fill this truth table with this shortcut. From y0 you will start 1, diagonally you will fill y1 in the up to y7 value and the output will be filled with, it has 3 variable, right? 3 variable is filled with, the first column is filled with 4041 and the next column is filled with 0011 0011 and the final column is filled with 0101. The logical expression of a0, a1 and a2 are written as, this equation is derived with the help of the K-map as I told you before. Draw the K-map for all the output. First draw the K-map for A2, afterwards A1 and A0. Then do grouping for all these three output. Then you will get a value equation like this. Y2 equal to A2 equal to Y4 plus Y5 plus Y6 plus Y7. A1 equal to y2 plus y3 plus y6 plus y7. A0 equal to y7 plus y5 plus y3 plus y1. With the help of these three equations, you can able to draw the logical diagram for 8 by 3 encoder. So in this equation, we will mention only this input y1, y2, y3, y4, y5, y6 and y7. For A2, what equation you will get? Y7 plus y6 plus y5 and y4. Okay, with the help of 4 input you will draw this OR gate. Like that you will draw our OR gate for A1 and A0. What is the uses of encoder? Encoder is usually used in multi-digital circuit to do the so many operation and function. Encoder are used to convert a decimal number from to binary number. If you have given the number as 8, with the help of the encoder you can use to convert this 8 number to 8 decimal number to binary number in 3-bit or 4-bit value. The main objective of the encoder is to perform binary operations such as addition, subtraction and multiplication. Next one is decoder. The decoder is opposite to encoder. Encoder have two power n number of output and it will provide n number of in output. 2 power n number of input and it will provide n number of output in encoder. But in decoder, the operation is reverse. That is, it's going to for n number of input, it going to provide 2 to the power of n output. For example, if you have give 2 input means 2 input means you are going to get output as 2 to the power of 2, that is 4. That is 4. Like if you give 3 input, 2 to the power 3, you will get 8 output. The binary information, that is 0 and 1, is passed in the form of n input value. So the given out input it will be either 1 or 0. The producer output is also given as binary information, that too in 0 or 1. Usually, the decoder is classified as similar to encoder: 2 by 4 line decoder, 3 by 2, 3 by 8 decoder, and 4 to 16 decoder. Here you will have 2 input and 4 output. In 3 by 3 to 8 decoder, you will have 3 input and 8 output. In 4 by 16 decoder, you will have 4 input and 16 output. First one is 2 to 4 line decoder. So it has usually 2 input and 4 output. The output will be mentioned with the variable as y0, y1, y2 and y3, and the input will be mentioned with a0 and a1. For each combination of input, when the enable is set to 1, one of this 4 output will be 1. You need to set this enable pin as 1 if you get any one of the in output will be 1 in decoder. So this is the block diagram. It has 2 input and this is the enable pin and 4 output. Truth table for decoder. Enable pin is 0 when A1 is given with indeterminate form, that is in don't care condition. During that time all will be 0. Okay, all output will be 0. In next, when you give enable pin as 1 and A1 as 0, A0 as 0, you will get 1 output in this 4 output. Afterwards, if you give 0 and 1 as input, you will get 1 as an output in y1, and the remaining 3 will be 0. Fourth input will be a1 is equal to 0 and a0 is equal to 0. Here you will get I output value in y0, y2, and remaining 3 will be 0. And final input will be 1 1, and y3 as high value, remaining y2, y1 and y0 will be mentioned with 0 as output value. The important thing is, if you get any one of the output will be 1, you need to do enable pin as 1. If you give enable pin as 0 means your in your both the input will be in indeterminate form. You need to derive this equation with the help of the K map. The help of the Kmap, you need to find the equation for y3, y2, y1 and y0. So it is very easy. When y0 is equal to 0, y0 is equal to 1, right? Do when a1, you need to write this equation in sum of product method. Sum of product method. When y0 is equal to 1 as an output, when a1 is equal to 0, a0 is equal to 0 and enable pin. Sum of product, you will write this equation with the help of the product of sum method. Usually consider encoder is written in the equation with the help of sum of product method. In decoder because you need to do product of sum method to write your logical expression. Usually decoder is opposite to encoder. That's why in encoder we will use sum of product method to write a equation. In decoder you need to use product of sum method to write the equation. First of all, write it down the equation for y0. Y0 is equal to 1 when a0 is equal to 0 and a1 is equal to 0. If a0 is equal to 0 means you need to mention with a1 dash, a0 dash and e is 1, right? So e is mentioned as it is. And next, y1 is equal to e when e is equal to 1 and a1 dash is equal to 0 and a0 is equal to 1. See here, y1 is equal to 0. During this time a0 is equal to 1, that's why we will mention as a0 and a1 is equal to 0, so you need to mention as a1 dash. Afterwards 1 enable pin is 1, so mention as it is e. Y2 is equal to 1 when is provide an output as 1 when it is a1 is equal to 1, so you need to write a1 as it is. Afterwards a0 dash and e is the enable pin. Last one is y3. When y3 is equal to 1, all the values will be 1. During that time the y3 is provide an output as 1, so all will be mentioned with the as the name itself. This is the logical diagram for decoder for 2 input and 4 output decoder. This is the logical sorry, this is the logical diagram for decoder, 2 input and 4 output decoder. So you will draw this circuit with the help of this equation. Wherever you mentioned the dash, you need to draw the NOT gate with that given input. Next encoder is 3 to 8 line decoder. In this next decoder is 3 to 8 line decoder. In this decoder you will have 3 input and 8 output. So the output will be mentioned from the variable I02 Y7 and the input is mentioned with the variable A02 A2. This circuit has an enable input pin E. Just like the same procedure is followed in this decoder as we do before. So 3 input and you need to mention one more input as enable pin. Okay, and 8 output. This is the block diagram of 3 to 8 decoder. If you have 3 variable means you need to fill 4041, 2021 and 0101 for input. Afterwards, in decoder, your output will be only one output will be get as high value at a time, and the remaining will be 0. First will be 0, enable pin is given as 0, and during that time the A2 and A1, A0 are in the indeterminate form. During that time you will get the output as 0. Afterwards the enable pin is enabled with 1, and A2 is 0, A1 is 0, and A0 is 0. If you give 3 input as 0, you will get output in Y0, and remaining will be you will get as low value, that is 0. Like that your output will be passed from one to another. Next time you will give 001 as input, you will get output in Y1, and remaining 7 will be 0. The same procedure is followed up to the 8 values. In last value you will give A2, A1 and A not as 1, and enable pin also here 1. Your output will be mentioned in Y7 as high output, and remaining 7 will be 0. Like the same procedure we followed in the 2 by 4 decoder. You need to write the equation from Y0 to Y7 with the help of the truth table. You no need to do grouping, because you will directly write this expression with the help of this truth table alone. Y0, when you will get Y0 as 1, when A0 is equal to 0, that's why you mentioned as A0 dash, and A1 is also 0, so A1 dash, and A2 is also 0, so A2 dash. Likewise, you need to fill the equation with the help of this truth table. You need to consider this one value to write the equation for all the output. This is the logical diagram for 3 by 8 decoder. So you will have 3 input, one is A2, A1 and A0. If your equation will be mentioned in the A dash or A0, A1 dash or A2 dash, means you need to connect with the NOT gate to get invert. So we will return the equation in the product form. That's why we will use here AND gate. With the help of this all the logical expression, you can easily draw this logical